Hello ladies and gentlemen, I wanted to do this quick little blurb about how to rationalize the denominator of any fraction. Now, I had a question from a student on this, so I wanted to see if I could help you guys out with it. Here we go. Now, here's our first example. This is just simply 6 over the square root of 2. So, here we have a fraction that has a root in the denominator, alright? A root, in most cases, is an irrational number. If you actually took a calculator and punched in the square root of 2, you would get a number whose decimal never repeats and never ends. An irrational number. So, to rationalize the denominator, to make it rational, we use this little trick. Alright? Now, it turns out that if you square a square root, it gets rid of the root. The definition of squaring is 2 times by itself. So I'm going to take the square root of 2 and multiply it by itself. But of course, with fractions, whatever you do to the bottom, you have to do to the top. So we're taking this first fraction and we're multiplying it by this really fancy version of 1. Alright, so as you guys probably well know, when you multiply a fraction by another fraction, then it's just top times top, bottom times bottom. So 6 times the square root of 2 is simply 6 times the square root of 2. No other way to say it. Square root of 2 times the square root of 2 is the square root of 4, which is also known as 2. Or you can just say root 2 times root 2 is 2. Okay? Now one more step here. The 6 and the 2 can cancel. Alright, there's no plus or minus signs that will keep me from canceling. So I'm just going to go ahead and cancel them right now. When you cancel a 6 with a 2, it becomes a 3. Alright, hopefully that's still readable. But your final answer is going to be 3 times the square root of 2. And everything in the denominator canceled out, so technically there's just a 1 there, and I don't have to worry about it. On to this example. Now, what if you have something more like this in the denominator? Okay? How do you get the roots out in this case? Well, we have a mathematical tool that we call the conjugate. Now, the conjugate is simply a repeat of this, what you see in the denominator, except for it's got a plus sign in the middle. So let's go ahead and times by the conjugate. All right, so I've got the square root of 5 plus the square root of 3. Just like last time, we're going to times the top by the same thing as the bottom. So here we have the square root of 5 times the square root of, plus the square root of 3. Now, since I have 6 times this, I'm going to have to distribute my 6 across this binomial. Or maybe I can leave it alone and maybe it'll cancel out. We'll see. Let's try just 6 times the square root of 5 plus the square root of 3. And we'll just leave it in this form to see what happens. On the bottom, this is kind of where the magic happens. This is why conjugates are used to rationalize the denominator. Now, a lot of times, when my students are multiplying a binomial by another binomial, they'll make the mistake of saying first times first, last times last, done. Alright? Now, I'm here to tell you that you can only do that in the case of conjugates. That only works with conjugates. Don't try and do it in any other case other than conjugates. Here we go. So I can do first times first, in other words, root 5 times root 5, which is 5. Last times last, root 3 times root 3, which is 3. And of course, I just multiplied a negative by a positive, so I've got a minus 3. All right, next step. Now I've got 6 times the quantity square root of 5 plus the square root of 3 all over 5 minus 3, which happens to be 2. Now, luckily enough, my 6 will cancel with my 2. Alright, so 6 cancels with 2 to become a 3. So my final answer, let me put it over here in the center where it's more easily seeable. We have 3 times the quantity, square root of 5, plus the square root of 3. Alright, there you have it. Ladies and gentlemen, I hope that helps you out. I was asked this question by a student. Thank you for the question. I appreciate it. I appreciate each and every one of you and all the work that you're doing. I realize you're all working very hard, and I really, really appreciate it. Thank you again. If you have any other questions or questions about this particular topic that we just covered today, please leave it in the comments below and I will see if I can clarify. Again, if you have any other questions, again, leave them in the comments below or ask me in person if you happen to be one of my students. Thank you very much. See you later.